we're going to do properties of quadrilaterals 1. So the first thing we need to do is we need to get out a piece of graph paper. This is the graph paper that I have available. So I am going to change this so that it is the X and Y axes. So I'm going to, instead of doing X and Y axes here, I'm going to make this all one thing. So this is X axis. This is the y-axis. And the first thing I'm going to do is plot these 4 points. For h, I'm going to go over 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and that's h. Then I'm going to go over 7, 2, 3, 4, 5, 6, 7, up 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I. Then I'm going to go over 11. So we've got 7, 8, 9, 10, 11, up 1. That's D. And then I'm going to go over 6, up 4. 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4. And that's E. Then I'm going to use another piece of paper to be my straight edge. Again, you could use your phone, you could use your Chromebook, whatever. Just making sure we're drawing that straight edge in here. And we're connecting it because we want to know what shape this is. And we're going to use a bunch of different things we've already learned to do this. So once we have this shape in place, we are going to find the lengths of each side. And we can do this a number of ways. The first few I'm going to use that Pythagorean theorem way that I've kind of showed you about. So we're going to do h to I. So h to I am going over 5 down 3. So that's 5, 3. So that's like we're going 5 squared plus 3 squared equals c squared. And so we're just going to do the square root of 5 squared plus 3 squared. And I just put that into Desmos or into my calculator all at once. And I get the square root of 34 or 5.83. Next, I'm going to do I to D. So you can use all the same color here. The only reason I'm using different colors is because it shows up better on the screen here. So for I to D, I'm going to go over and down, and I went over 4, down 10. So again, I'm going to go 4 squared plus 10 squared equals c squared, and then take the square roots. And we're going to end up with a square root of 116, and that is going to be approximately 10.77. Next, we're going to find E to D. E to D. So E to D right here is over 5 up 3. Over 5 up 3. So it's the same thing. We're going to go square root of 5 squared plus 3 squared. And we're going to get that square root of 34 or 5.83. Notice these two things are the same. Next, we are going to do E to H. So we're going to go over, and we're going to go up, and we're going to go over 4 up 10. So when we do that, we are going to get, and I'm going to try to zoom in just a little bit. Hopefully this works. There we go. When I do that, I'm going to get E to H. Gives us, again, that 10 squared plus 4 squared, which gives us a square root of 116, or 10.77. Notice these two are congruent. So right here, I've got two sets of congruent sides. Next, we're going to talk about the slopes of these. So if we look right here, the slopes are kind of given to us. So I'm going to do h to I again. And if I look, h to I is I go down 3 to the right 5. If I look at I to D, I'm going down 10 to the right 4, which I'm just going to reduce to negative 5/2 because it goes into there twice. Next, I've got E to D, which is giving me 3 down up 3 over negative 5. Those are the same thing. It doesn't matter that the negative 3 is on the bottom or not. And if they are the same, they are parallel. So I have a set of parallel sides. And then if we're looking at E to H, I'm also getting 10 over negative 4, which is the same thing. It's 5 over negative 2, which those are the same thing. So I have two sets of parallel sides. Now, diagonals, I want for this diagonal, I want H to D right here, this whole long one. And so instead of doing it like that, I'm going to show you how to do that using the distance formula. So for here, if we're going to find the length of H to D, and I'm just going to rewrite the points H and D down here for me. H is 214, D is 11.1. I'm going to list them as x1, y1, x2, y2, and I'm going to stick them in the square root. So I'm going to go square root of y2 minus y1 squared plus x2 minus x1 squared. And I just put this in my calculator all at once, and I get the square root of 250, or about 15.81. And then I'm going to find the slope of this. And I'm just going to do the slope formula. I'm going to go 1 minus 14 over 11 minus 2. And I get negative 13 over 9. Now, I could have done these slopes and these distance formulas up here the same way. I just wanted to show you both ways. Then we're going to look at I to E. Okay, I to E, the points are 6, 4, and 7, 11. It doesn't really matter which way you write them. You could have written them the opposite way. You would have been fine. We're going to label them x1, y1, x2, y2. And we're going to go 11 minus 4 squared plus 7 minus 6 squared. And we're going to get the square root of 50, or 7.07. And then we're going to find the slopes of them, because that's what this says here. The lengths, which is the distance, slopes, which is slopes. So we're going to go 11 minus 4 over 7 minus 6. And we get negative 7 over 1. So these are not congruent, not parallel, or perpendicular. They are neither of those things, nothing. So we're going to find the midpoints. The midpoints means it bisects. So we're going to take these and these again and find the midpoints of them. Remember, midpoints is adding the x's, divide by 2, adding the y's, divide by 2. So we are going to end up with 13 over 2 and 15 over 2. You can change them to decimals if you want. And then we're going to use these. We're going to go 6 plus 7 divided by 2. And 4 plus 11 divided by 2. Remember, with midpoint, you put the little comma in between. You're not adding them together. And we get 13 over 2 and 15 over 2. These are the same. Therefore, they bisect. We have bisecting diagonals. Diagonals that cut each other in half. So, because we've written this down already, we have two sets of congruent sides. Two sets of parallel sides. We don't have any congruent diagonals. We don't have any parallel or perpendicular diagonals. You can't have parallel. It wouldn't make sense. They're the diagonals. They cross in the middle. But they're not. And they're bisecting. We know it is a parallelogram. Parallelogram. Because opposite sides are congruent. Opposite sides are parallel. And bisecting diagonals. And this is how we do properties of quadrilaterals.